In this project, we will create this bathtub toy. It's a fishing rod with a Pokemon ball and 3 figures. So we will look into toy design. Toy design is actually a pretty interesting topic. While a toy, it still follows, actually, if you want to see it this way, form follows function. We still have to design something for somebody to use and interact with it and enjoy it. And if we want to do valuable toy design, there should also be an educational benefit to it, stimulating, etc. So toy design is actually or can be quite hard. And what I really like about toy design too is it allows you to be very creative. Designing an iPhone is a little bit less creative. Okay, so in this project, we will also look into texture painting. So all the colors you see there are either done via basic materials, or we kind of like spray paint them on the geometry, which is a pretty nice way to do. This is different than projecting a decal like a sticker or label onto a packaging or product. Here in this case, we will really paint the stuff. So pretty nice. We will start with the figures first, and then we will do the fishing rod. And we can look at the octopus first, then we do the fish, then our little one, and then the rod. All the files are being supplied. Let me go back. So you have the reference folder with these images for dimensional scale. There are some photos with overlays to give you all the dimensions. And there's also a folder with some pictures for the fabric and also the face. And I'll show you, well, you might think, hey, we can just draw it this way and then project it on. There are some downsides to doing this, which makes painting it onto it actually better. And then here is a quad ball. You might ask yourself, well, what's a quad ball? I will actually talk about this in a moment. And the zip file for this is in the description as a downloadable link. Very good. Here you also see I used Gravit Designer to quickly create an overlay. This is a smile, which maybe could be used as a stencil. And I'll show how this works and also the downside. In here, based off a photo I created myself, a little illustration, and recreated the design more flat. Okay, very good. So let's go to Blender, download the file, and then import the OBJ file. And I have to go to there, scroll down, and it is somewhere. There's toys, way too many projects. And there it is. Okay. How we bring this in doesn't really matter. Good. So there is this one. And let's also bring in as a reference. Now we can use reference. We use this one here, over Octopus. Okay. The octopus is there, so you see this is actually kind of small. This ball, when I press N, is actually huge. Let's say this actually should be 45 millimeters. It has more. The size actually should have. Very good. And we can move. Actually, don't move this anywhere else. We take the image, scale the image down. And then, oh, what did I do? Oh, yeah, I see what I did. I changed the offset here. Here and also here, let's make this size millimeters. Yeah, so everything is size-wise similar. Okay, so what I wanted to point out now and actually show you is everything here they modeled actually with very basic geometrical shapes. Perfect spheres, perfect cylinders, perfect domes. It makes it look a little bit very geometrical. And we will make this a little bit nicer. But there are some details or tricks we need to be aware of. So here is actually our quad ball. So what's a quad ball? Essentially, if we make a sphere, and here in the sphere, we also set to 45 millimeters. Here we can see that the sphere and the quad ball kind of like, you see these points that touch really in it. Now, if we add a subdivision surface modifier, make this nice and smooth, and then scale this one up a little bit. And there you can see this matches this actually really well. So the quad ball is actually a low polygon geometry where all the points are positioned so that this nearly looks like a perfect sphere. In contrast, here's a cube. And this cube we will make round, scale this up, and there you can see, yeah, this looks like an egg. This is not perfectly round. There is a distance, here touches it. There you can see that. Which is why we cannot actually work with a cube. We have to work with a quad ball. Okay, so the reason why I'm pointing this out is here you see this is a cylinder and a dome. Okay, so in basic polygon modeling, what we could do is, yeah, well, move this over, Shift and X, move this one back to edit mode, AA, go to wireframe mode, select this, delete it, select this, E and Z, move this down. Yeah, here's the shape. Perfect cylinder at the bottom and a perfect fitting dome on top. Works well. In Fusion, for example, or CAD program, we would draw this also in a similar way. Our goal, however, is in the process I teach that everything what we do in Blender does not stay in Blender. We can use it as a modeling environment for subdivision surface type, and then bring the geometry over to Fusion to finish the modeling there. But Fusion is an engineering tool. So for modeling precision, it is great. It's not, however, the best for exploring this as an idea. Also not for rendering, not for painting, not for sculpting, etc. And this type of geometry here, you see here, these are triangular points. This is not something really we want to bring over actually to Fusion. So what I'm talking about when I turn the sub-D surface on and shade smooth, and you see there what's going on. This is bad. So we could select this point, delete it, alt-click this edge, F, then we have an N gone, and then it's also bad. Yeah, okay. Essentially, the trick is very simple. We can't use this type of geometry because here this pole is a problem. The rest is all quad faces, so that helps. But hey, this is all made of quad balls. No matter where I look at, you see the poles, it's all quad face. Okay, interesting. So to rebuild this, what I'm showing you right now is just basically an understanding for geometry and also the downside of subdivision surface modeling and how we um, improve on it. So Shift E, X moves over in edit mode, AA, delete all this. There we select this, E and Z, drag this down. Ah, perfect. Yeah, it looks nice and smooth, but you can see that this does not look like a circle anymore. This is very organic. Okay, well, we can add a loop cut. Let's do this. Zip. There, now we have a nice cylinder, and yeah, this doesn't look as nice anymore. Okay, well, we could go ahead and then select these points and scale this out, and then, well, way too much work, and that's the chances are the stuff gets very irregular. So that's till we are back to here. So what do we, with this geometry, get however to a shape like this? And the trick there is very simple. This is a too low resolution cage. We need more points. So you see here, I went to levels viewport 1. You see all the faces. I can go higher, but that's not really necessary. 1 is actually sufficient. And then I click apply. Then I go into edit mode, Z and wireframe, AA, B, X, this E and Z. I extrude this down just to make the faces a little bit the same. E and Z, there. Shape smooth. Subdivision surface, and look at that. Now this looks actually much closer. So we bring this in. Here we set this to 0. And we set this one to 0. So they perfectly overlap. Okay. Then I'm going to scale this up a little bit. So you see where it starts to not match up 100%. So if we want, we could select this S and Shift C. Now we change it a little bit. But you saw actually this is much, much rounder. This is not, however, this is still not 100% half a dome and a perfect cylinder. But that's also why I really dislike this G1 transition here. I simply hate it. It looks nice and basic, and that's also where I feel like, blah. Um, the main body can be a sphere, fine. This can be a cylinder, fine. But the rest, hey, come on, we can do this better. So this type of geometry is perfect. Huh? Subdividing this a little bit and then having these arms to come out. Now, you will see how we then continue developing this is by rebuilding all these individual elements and then putting the geometry pieces in, and then via the boolean command in Blender we will join them together so we can see them as a unit. And the cool thing is, once we prototype this in Blender, we can zip it over to Fusion and, for example, give the engineer the CAD data to do the injection molding, etc. Okay, so let's delete all this. Here, this one we bring to 0. I will set this to 4 just on purpose. So I have really high surface definition. If I want, I can even go to 6. I do 6 here only because this is just a very basic cube. And you see how many faces we have there now. Okay, so why did I do this? Now actually the surface is very smooth. Fusion in the sculpt mode, so T-splines has advantage. It does not go in levels like here. It goes essentially from this to perfect. And I'm just trying to figure out this perfect surface. And now I will go ahead. What did I measure here? Yeah, 45 millimeters. So I override this. So now I can set this to 2. You can see we get some facets back. And this geometry, now when I would send it over to Fusion, will really be 45 millimeters diameter. This has a scale factor. So let's apply the scale factor. And there we are. Very good. Cool. Okay, so there is a small cylinder here on top, 12.5 and 12. So how can we do this? We can actually select this ball, Shift D, copy, GNZ, and this is actually X, so 12.5 millimeters. Very good. And then this will be Y2, 12.5 millimeters. Oh, it's rotated. Wah, wah. Okay, 12.5 millimeters. Very good. Here's both and say apply scale and rotation there. So then we'll go into edit mode, AA, Z and wireframe, select this and this. Actually, no. Middle mouse button, deselect this and X and delete. Very good. Now select all this. S and Z and 0. So we see we collapsed it. And turn on vertex for snap. And then move it down and we snap it to there. So you see there how we have a nice interior set. These points here, I can select X and say dissolve edges. Ooh, that was not good. Interesting. 1, 2, 3, 4. Okay, then, okay, we'll do this manually. Dissolve vertices, okay, and then here I have a face. See, I simply simplified the geometry. Oops. 1, 2, 3, 4. Select all the outer points. Or actually, we can do it this way. We select all, E and Z, or E, Z, here we are. And then I select all points on top. Okay, and then this I will crease. And then I will do exactly the same with the points here at the bottom and crease. So I sharpen that. Very good. And I set a height of 2 millimeters. So this is Z. Let's say 3. Actually, I go 4 millimeters. See why in a second. Apply scale, shade smooth, and turn on the edge. Go to a side view. Then I move this one down. Move this up. Hold the control key. Does it snap to it? Yes, it does. So, or I move this down a little bit to there. So now so you see, this is kind of like where it starts to touch through it. Okay, and now I would like to move this up by 2 millimeters. So easy. And escape because we are in meters. So let's set units to millimeters. GZ to enter done. So 2 millimeters. Very good. I was actually trying to see, does this change much? I keep this as 4. Okay, this is easy. So, and there again, you see it starts to stick through. GZ2, zack. So here later Fusion will create a fillet and we will round this edge. Like you can see here, this is slightly rounded. That's something we would do in Fusion. Oh, look, what a beautiful Christmas ball. Okay, so that part is done. And never forget also to save. So now we have 1, 2, 3, 4, 5 of those arms. It has a length of 8.5 millimeters. It has a diameter of 9.5 millimeters, and there's roughly a millimeter of a distance between these arms. The easiest way to start is just modeling the central one. So we can select this, Shift D and Escape. Move this one down. Now you remember we want to create at least one subdivision, so we have a higher definition. And Z. So now this is actually, we can't go in and now adjust the height. So this should be 8.5 and diameter should be 9.5. So here we can type in 9.5 millimeters. And you see there's a scale factor. Cool. So this I can copy and apply this to Y. And to Z, see by applying the scale factor, it sets the scale proportionally correct. Pretty cool, huh? I know. It's awesome. Apply scale. Now this is 11 millimeters. Okay, how do we get this to 8.5? Same deal actually. We bring this to the edge and then we just drag it out 8.5 millimeters. That's that easy. So this one we can move up a little bit. Now we have actually a lot of points here. Now I'm curious, how could we close this? So F, and then here, let's see, F, and then 1, 2, 3, 4. 1, 2, 3, 4. But then I have center points. I don't really like this. So I would like to simply cap this. That's the main reason behind it. And there's actually probably my little answer. 1, 2, 3, 4, 5. So I'm just selecting this surface area here. Shift D and escape. GZ and 0. F Z and 0. GZ up. GZ hold control. Snap. And yeah, see all these edges actually line up. So Alt click on all these edges with Shift and Alt, left mouse button click, edges, and bridge. Ooh, okay, maybe not. So you see there's some interesting stuff going on. That's because probably, yeah, faces are flipped. So A, Shift N, there we are, and turn this off. Now we can see if we select all these edges, and we now can do the bridge. Yeah, there we did. We helped the software a little bit. Shade smooth. Oh, that's under face. And then auto smooth. Very good. Okay, very nice. Yeah, so you see like a dome, essentially we collapse into a flat face, and in this way we get a really nice rectangular piece. So then we can give this a subdivision of 2. Oh, by the way, if we do this, I forgot that this edge needs to be creased. And So we can bring this to there, and then G and Z minus 8.5. So 8.5. You can actually see roughly where it sticks through. So if I bring this up more, yeah, is this actually really 8.5? Here's a measurement tool. Oh, look at that. Whoa. Very good. Okay, very good. Perfect. So a little other trick, it's kind of low tech if you want to see it this way, but hey, this is essentially borrowing from drafting. There, we made a rectangle, R, X, and 90. There's my rectangle, G and Z, and bring this one down, push it to there. Okay, so this is really 8.5 millimeters, and then you go up, you go down. There we are. Suck. Ta-da. Awesome. Maybe now we want to also save this. I call this do we get those over now? Now we want to have 1 millimeter of a distance. Let me actually undo deleting this, and I will make the X to be 1 millimeter. Very good. Now the 3D cursor comes in, being super useful again. 3D cursor, Shift S cursor to world origin to make sure it's there, and Shift D and R, and then we rotate it, and R, there. Very good. So before we continue, also let's give these things name. So this is actually money, and this is socket, and this is tentacle. I spelled correctly. What do I have here? And we can call this spacer. More clear. There's actually somewhere else. It's another spacer here. We can keep this spacer 1 millimeter master. And empty here, that's our reference. Very good. Now, this one. We will actually not Shift D, but Alt D. So Alt D and R, and then rotate it to there. Okay. And then you can see here the rotation for it. And we use the 3D cursor for that. Now you see how we rotated this. And select this. Shift and R, and then Alt T R. I do an Alt T obviously because this way if I adjust one, the other one is adjusted. There. See? Easy. Now how do we do actually the next two? That's kind of fun too. Select these two. Alt D R, and now you press Z, and we rotate them over 180 degrees. So 180, enter, done. What happened? Good, let me show you again. So this one here, we always pressed, because we were in orthographic view. So essentially we set Shift D, R along the Y-axis and bring them up. So these two now, because we want to mirror them over, so we simply say Alt D to make a copy, go into rotate command, so R, and then around the Z axis, we rotate them over 180. Yeah. And that looks actually pretty good. So I would like to show you one alternative. I delete those. And where the 3D cursor is, I will select this one, right click and say origin to the 3D cursor. So it's there. And that has actually, when we do it this way, one a very interesting advantage. Because this is the center of rotation. When I press Alt D and then simply R, so now I can see how much did I rotate this. 0, 25 degrees, 0, 26 degrees, 5 degrees. Okay, good. Yeah. When I now say Alt D, escape, so 26.5 degrees multiplied by 2 is 53 degrees. So I'm actually not eyeballing the distance between these two objects. I, from the center, always do the rotation. Now, when I go to here and rotate around the 3D cursor, so Shift D, I'm making just a copy, and then say origin to geometry. You see, so it's back to there. I'm still in 3D cursor, and I rotate this by, what was it, 26.5 degrees. You see actually, yeah, it's pretty much the same, but look what happens when I set this to 0. See? When I select this one and make this 0. So it's not really that this way is better, but for if at one point the client says, I would like to quickly make this 28. Okay, 28. And then here, this is 28 multiplied by 2. You see it's much quicker. Because here, if I there type in 28, it just rotates it on the spot 28, not around there. Yeah? So very good. So Alt D and escape. Alt D and escape. And we simply invert the values here. Suck. There we are. Awesome sauce. Very good. So a lot of the stuff is done. So this is actually pretty good. Now let's clean up our design a little bit. We call this construction. And all this goes into there. So just this one we want to keep. Safe, by the way. And now we will add some booleans. So union, duplicate. So 1, 2, 3, 4, 5, 6. Duplicate, duplicate, duplicate. 1, 2, 3, 4, 5, 6. Very good. So then we can start here. You bring this one in. And actually here, I will hide this now. So it's easier to see. This, you see the artifact there? That's because this one isn't turned on yet. There, it's gone. And I could call this socket. So I know actually what command this one is doing. And then here I could say, I could click on this and then say tentacle one. And no, actually, this is tentacle one. This one is tentacle, the center there. I mean, if you're OCD, you could also say, well, the last one has to be really from here. It goes over 3 and 4. Very good. Yeah, you see? So basic objects, and then we add all these elements to it. Maybe here our, this is actually, I put this one to there. We don't need this collection that can go. And this reference I put out. Maybe the reference I would like to see a lot, but I don't need to see all the boolean objects all the time. Pretty good. Okay, so this was basically part 1, how to model this, this figure. We're subdivision surface modeling and trying to simulate actually more this geometrical quality of this toy design. And then in part 2, we will go ahead and add all the materials.